In an exam, especially.
Okay, so we've looked at the arithmetic. Let's quickly have now a look at the geometric. Okay, so the geometric, the basics are still the same. A sequence is term 1, term 2, term 3. Series is term 1 plus term 2 plus term 3. No difference there. The only difference here is that my general term is now, or my terms are now multiplied with consecutive terms. So if my first term is still just A, just represents alpha, or my first term. My second term would be multiplied with a constant number every time. So the second term would be, if my constant, if I'm multiplying with the value R, what would the second term be? If I multiply with R, it would be AR. So my third term would be AR squared, because I've multiplied with R twice. My next term would be AR cubed. So my general term, in other words, a random term, would be AR to the power of what? Okay, now notice n minus 1. Again, notice that my first term doesn't have an r. So I would have to subtract 1r from my n. Does that make sense? So my second term has 1. My third term has 2. My fourth term would have 3. So my general term would have 1 less than the term number. Make sense, huh? Okay, so let's look at the series. Okay, well, let's look at those first. So if I wanted to find R, just like for D in arithmetic, I could use any term minus the previous term. In R, I can take any term and divide the previous term, because this one will have 3 R's, that one will have 2 R's. So if I divide consecutive terms, I would just be left with R. The A's will cancel, and the first term's R's will cancel with the next term's R's, leaving 1 R. Makes sense, huh? So in other words, I take any term divided by the previous term, and that then gives me my what I call the geometric property, that term 2 divided by term 1 is equal to term 3 divided by term 2. Or again, it can be any term divided by the previous term is equal to the next term divided by any term. You see these two, as long as these two are the same, these two can be consecutive terms. Okay, so let's play with this again a little bit, see what we can work out. So let's try and remember in the previous one, we took that middle term, term 2, and we saw that term 2 is the average between term 1 and term 3. Remember that? Yes. Now let's see if we can do a similar. If we multiply both sides with T2 and T1, in other words with the denominators, I see on this side T1 cancels, so I get T1 squared. Sorry, T2 squared. T2 times T2 is equal to T1 times T2. And so T2 by itself is the square root of term 1 times, sorry, not term 2, term 3. Okay, do you see that? It's actually plus minus. It could be because I'm taking the square root of it. It could be plus minus. So this one is different. It's not the average. It is actually a type of mean. T1 plus T3 divided by 2 is called the arithmetic mean. Mean. This is called the geometric mean. So mean just means the middle value between two values. So not really the middle value, the average. Mean actually means the average between two values. But when my two values, the relationship between them is exponential, then I can't use arithmetic mean, I use a geometric mean. Yeah. Yeah.
But I don't know if maybe I use some of the information that I took that
Yeah.
to get T2.
Yeah.
Would that be fine?
It would be perfect if you could find term 1 and term 3. Or again, this could have been any consecutive terms. So this could be term, let's say term n is the square root of term n minus 1, the previous term, times term n plus 1, the next term. So you could do that if you could somehow find the previous and the next term. Maybe they give you two terms like that. That would be easy. They can even ask you in an exam to prove this. Prove that that is true. As an example. Okay. What else what else did we look at in the previous one? We saw this. Okay, well let's look at the remember in the previous one we saw that the arithmetic sequence has actually a relationship with the straight line. What does this one have a relationship with? Keeping in mind that my Tn is my y value and my n is my x value, because n is what changes and t is what changes because n changes. So this one is a r n minus 1. So this is like saying a r x minus 1. What relationship do we have here? What type of graph is this, or function is this? That's exponential. Now we don't have such simple things to work with like gradient and things like that in the exponential function, but it does give us some sort of idea when it comes to the converging and diverging, because we know that when my base, remember we looked at that last week, if my base is bigger than 1, then my graph looks like this. Now the only difference between number patterns and actual graphs, functions, is that I'm not working with x can be any value. So x can be 1 or 2 or a half or a quarter or 0. What or negative values. While, so in other words, if I draw this graph, it will look like that. While when we work with number patterns, n can only be these values, so it would look like this. Instead of being a continuous line, it would be this little dots, but they will fall on that same shape. We just wouldn't have the values in between. This is what it would look like. We will literally not connect the dots. Okay, so the idea is still the same, and we won't go to the negative side. Now, what we do know is that when we're working with an exponential function, is if my base, or in this case my base is r, if my base is between 0 and 1, then my graph looked like this. You notice, and now it is, so here it's diverging, it's going to infinity, so it's diverging. And here, if I now plot my dots on this one, my dots will start going closer and closer to 0. You see, it's approaching the asymptote, and that is what we call converging. Okay, so converge means it's approaching an asymptote. And it converges when my constant ratio is less than 1. Okay, but the only difference now is when we use graphs, my base could not always had to be positive, while here my constant ratio doesn't have to be positive. In other words, my constant ratio could be negative. In which case, if my constant ratio is negative, and that's why with graphs we can't do that. We can't draw a graph with a negative base, because now look what happens when I plot the dots if my r is negative as well. So let's say my r is now bigger than -1 but smaller than 0. It's still so in other words, it's negative. Then when n is 1, I will have a negative answer. I'll do that in red. When n is 1 I'll have a negative answer. When n is 2, I'll have negative answer squared. So I'll have a positive answer. So I'll be there. If n is 3, I'll have a negative answer to the power of 3. Actually, it's the other way. I'm lying, sorry. When n is 0, I'll just have a, whatever a is. So let's say that's a. No, not when n is 0. When n is 1, I'll have a. So there's my a. Let's get back there, sorry. There's my a value. A. Now, I don't know if I'm not going in the wrong direction. So this is term 1. Term 2 will be a times r, but now r is negative. So my term 2 is now negative. Term 3 is now a times r squared, but now I'm squaring a negative, which makes it a positive again, so now I'm positive again. My next term, term 4, is ar cubed. So a negative and a negative and a negative gives me a negative again. So this will be negative again. And then it will be positive again. And then negative again. And positive. So obviously I can't draw a graph like that. Because not just that, is if, for example, if I have something like -1/2 or -2 as my base to the power of 1/2, because when I draw a graph, my x can be any value, not even -1/2, just 1/2. And this is the square root of -2. What's the square root of -2? Okay, not in real, we can't draw it. So this graph, for one, if I were drawing x's and y's, and x can be any number, then you literally can't draw that graph. Okay, it would be like dots all over the place doing something like this. Okay, so it doesn't work. But when we have that my x is only counting numbers, then I will have one on top, one on the bottom, one on top, one on the bottom. But notice how it's still coming closer and closer. Even though one is the top, one is at the bottom, it still starts coming closer and closer to the line. If r is negative, but it's still between 0 and 1, -1. If r is negative, but it's smaller than -1, then it will look like this. It will start at a, but the next one will be bigger, and then there, and then there, and then there, and then there, and there. So do you see it's still going to infinity, so it's still diverging. So the only time it converges, the only time it's approaching a limit, is when my r is less than 1 and greater than -1, a constant ratio. Okay. I didn't like that discussion. I don't know. Well, I don't know if you learned something.
So sorry, can you please repeat when it converges, r is?
Between 1 and -1. I can look a little bit later exactly why. Okay, but now if I have a series, I'm now adding these values. So I'm going to show you the proof for that as well.
Sorry, sir.
Yes.
So the sum of infinity is always convertible.
No, depends on x. Not x. It depends on r. Only converges if r is between 1 and, but we'll look at sum of infinity just a little bit more. Okay, so let's just look at the sum, not to infinity, but the sum okay, so let's look at this. The sum n is now the sum of t1 plus t2 plus t3. You guys get this now, what we mean by the sum Sn. Okay. Now I'm again going to show you the proof. And how do you prove the formula? Where does the formula come from? And so obviously we start with what is the sum. This is usually your first mark, just for writing that out. Your second mark goes for actually substituting each of these values with what it would be in the arithmetic or geometric series. So this one would be A, term 2 would be AR, term 3 would be
AR squared.
Now this one you are going to literally go to the second last one, which is AR n minus, so the last one would be AR n minus 1. This one would be n minus 2. Okay, so this time it is going to be important. And then the next step is again one of those trick test steps. So what did we do in the arithmetic series? After this, what was our next step? Can you remember? Yeah, you wrote it in reverse and then you added it, isn't it? Okay, so, or subtracted it from each other. No, you added it together. This one, you're going to take this expression, this whole one, and you're going to multiply everything with an r. So you multiply the left hand with an r and everything on the right also with an r. Okay, and the reason why, now notice, if I take the first term times r, I get the second term. And then if I multiply this term with an r, I get the third term. And so if I multiply this one with an r, I get the fourth term. And then there's a bunch of terms that I don't know. The one before this one would be ARN minus 3. And if I multiply it with r, I would have ARN minus 3 plus 1, because I add exponents, isn't it? And that becomes ARN minus 2. So if I take the previous one that's not written here, I would get ARN minus 2. If I take this one, I add another r, I would get ARN minus 1. And then I take this one and I add another r and I get ARN. You get that? And now what we're going to do is, again, similar to the other one, we're just going to subtract this. This is 1 and this is 2. And I'm just going to say, let's take equation 1 minus equation 2. So on the left hand side, we have Sn minus Rsn. And on the right hand side, this a has nothing to subtract. So it's a minus 0 is just a. But these ones cancel out. AR minus AR squared minus AR squared. AR cubed, it's not written here, minus AR cubed. All the way up to this one, ARN minus 2, ARN minus 2. ARN minus ARN minus. And then there's 0 minus this one, minus ARN. Okay? And we did that so that we can eliminate this these phantom terms here, the terms I don't know that should go in there. Is that okay? Okay. And now it's really simple. Remember, I'm trying to get a formula for Sn. So I'm just trying to solve Sn. To solve Sn, I take it out as a common factor. So I'm left with 1 minus r. And on the other side, I'm going to do the same thing. I take a out as a common factor. I'm left with 1 minus r to the power of n. And then I just divide both sides with the 1 minus r. Nice, huh? So there we get Sn is a. And guys, They ask these proofs almost every single exam. One of these two are going to be asked, I'm sure of it. Can't remember about the prelims. They almost always ask them. Okay, one of these two. Now the proof for the infinite geometric sequence. Yep.
Last year my teacher said that because you see the denominator of 1 minus r, in some textbook it is written r minus y.
Yeah.
So he said that if r is bigger than 1, then r minus y. But if r is smaller than 1, we say 1 minus r. Is that applicable?
Yeah, you can do that. So in other words, you're just simply turning these two terms around and those two terms around. So basically this can be written as Rn minus 1 divided by r minus 1. If you turn both around. Yes, because if, for example, if I say 2 minus 4 divided by 3 minus 6, what do I get in the top? So ignore this just now. In the top I get negative 2, in the bottom I get negative 2. Now if I just swap negative 3, if I just swap the top around, and so in the end I get 2 over 3. If I just swap the top around, I get 4 minus 2 over 3 minus 6. So I get 4 minus 2 is 2 over negative 3. So do you see now, it should be positive, and now I'm getting a negative answer. So I must also swap the bottom around. So if you have terms, for example, where it's a x minus y over b minus a, then it's the same as saying y minus x over a minus b. You can swap the terms around as long as you do it for both terms, for both top and the bottom. Because when you swap a subtraction around, you're changing the sign. 2 minus 4 is negative 2. 4 minus 2 is positive 2. So when you swap them around, you're changing the sign. So if you swap it at the bottom, you're changing the sign back. Make sense? So yes, you can do that. The only reason why you would want to do that is so that you don't have, so for example, if r is greater than 1, then you have in the top greater than 1 minus 1, greater than 1 minus 1. So you have a positive and a positive instead of a negative and a negative. But what difference does it make? Why remember two formulas and an extra thing when you just can remember one formula that will always work? And in the exponential, sorry, the infinite one, this term just cancels out. And you have a over 1 minus r. You see, so there's literally one formula that works for 3 scenarios. Well, in your case, you'll have to flip between them and try and remember which one to use when. Okay. So I don't recommend it, and I don't teach like that. Okay. Oh yes, the infinite. Okay, so for infinite, it works exactly the same. So we've got S infinity. The only difference is now I've got term 1 plus term 2 plus term 3 plus, and it goes infinity. And now for S infinity, for a geometric sequence, it's A plus AR plus AR squared plus AR cubed, etc., etc., etc. So I do exactly the same. I multiply everything with an R. The only difference is I don't ever stop. Okay, so the first term, I'm going to just move it up so that they fall. So I'm multiplying that one with an R, that one with an R, that one with an R, this one with an R, and now I subtract. So I get S infinity minus R S infinity is equal to, A has got nothing to subtract, But all of the rest will always have something to subtract, so that we won't have what we had here, where we had this last term for the bottom. We'll always have something to subtract. And so now I do the same. I take s infinity out as a common factor, and I just divide it on the other side. That's an easy proof, huh? Okay. Great, but once again, you see, all of this can, I mean, everything really just repeats itself. So, for example, they can give me two terms. Let's see how that would work. If I have term m, ARM minus 1, and I've got term n, AR, so they've given me two terms, and they asked me to find something. Okay. Now notice what we can do this time. So in the previous one, we did that change in Tn over change in n. That was if it's arithmetic, because, and this is gradient. Okay, that gives you your gradient, which is your constant difference. Okay, here we don't have gradient. We want to find our base. Find base, I wonder what I'm going to use. Okay, so this time I will use, just like here, I find difference, constant difference. This is actually what you're working out here is the average difference, which is constant. Okay, so here we're going to take the constant ratio. So I'll divide both sides. So I'll have Tm divided by Tn is equal to ARM minus 1 divided by ARN minus 1. The a's will cancel. The bases are the same, so I can subtract exponents. So I get R n minus n. So I get m minus 1 minus n minus 1, and that just becomes m minus n. You get that? Okay. Is equal to Tm over Tn. And now how would I get R on its own? Not really. You get logs if you want to get the exponent on its own. Okay, but root to the, but it would be, so this, let's call this m minus n, the change in the term numbers. So this would be R is the change in the term numbers is equal to the ratio of the terms, and then to get it on its own, we will just take that on both sides. So R is the whatever the difference is here divided by the terms, the ratio between the two different terms. Okay, that's just one. Again, you don't have to go and remember these formulas, but the process would be exactly the same. If you wanted, if they gave you these two, this is exactly what you do to find the constant ratio. You would follow the exact same steps. So you could as well maybe try and remember that, but I mean that's actually a complicated formula to try and remember. I don't recommend it. What else did we see? We saw, we can now see that the sum, and now if the inside here has any form where I call this my, what do I call it? Well, the variable, whatever is down here, if that one is in the exponent, then what type of series is it?
What type of series?
You know, no, if this inside here is linear, then it's arithmetic. If the inside here is quadratic, what do I mean by not quadratic, exponential? In other words, my unknown or my changing value is in the exponent. it means it's geometric. Look here.
So I don't understand what you're saying.
So look, in my general formula, Tn is equal to ARn minus 1. Notice the value that's changing, the n, is in the exponent. That's why this is geometric. So if I have a sum function and the inside of the sum, this inside thing here, has this value that's in here, that's the value that's changing, that's your n technically, okay? That means that this would be a geometric. So for example, they might give you this equal to some number, 3287, whatever. And so you know, oh, this side is the sum of the first n terms of a geometric. So again, you could have followed what Olivia would have said earlier. I could just substitute each term. I could find term 1 plus term 2 plus term 3, and I could just find the terms and then discover what type of sequence is it by either looking at a constant difference or a constant ratio. That's a sure proof way of getting it, but you could also recognize it from the beginning. That if my unknown is in the exponent, it's geometric. Just like in here, my unknown is in the exponent, so it's geometric. Okay. I can sincerely not think of another way they're going to ask this type of thing, so let's quickly look at some examples from the test, from the assignment. Okay, we had that one here. How many terms are there in this sequence? Okay, or in this sequence, because it's not got pluses in. How would we go about that? Okay, because we know what the last term is, we'll go and say, well, term Tn is equal to 36864, 36864, and now we just need to find out, well, what type of sequence is it? Is it indeed arithmetic or geometric? So let's just see, 936, 144, 144. Now usually we can use 570, 576 because a quadratic, we've not looked at quadratic, but quadratic you'll need 4 terms. But we could find, we say it's geometric. So let's just find the constant difference first. You can even see constant difference is not going to work. Because in a constant difference, this one must be in the middle between those two, remember? Term 2 must be in the middle of these two. And we see that's not true. This one is much closer to 9 than it's to 144. So it's definitely not arithmetic. So we can try then geometric. We see 36 divided by 9, 4. 144 divided by 9. And that immediately gives me, I like to write it like this. Then I've got my A and my R. And so I can substitute on this side and say, okay, I've got A, R, N minus 1 is equal to 36864. I have A is 9, I have R is 4, and I need to calculate N minus 1 is 36864. So how would I go about solving for N? Can you use it immediately? We must first remember, if I want to solve an unknown in the exponent, I must first get my base exponent by itself. Okay, so what am I going to do? I'm going to say 36n minus 1. Thank you for saying no. And so we'll give her a clap thing. I'm serious, I'm going to have to lose it.
It's going to be 36 to the power of n.
It's not.
3 that equals to n minus 1.
What? I can't give people an answer. Say again.
No, it's fine.
No, say what you're saying. I'm maybe not understanding.
Isn't it? Okay. First can you explain it and then.
Yes.
9 times 4 to the power of n times 4 to the power of negative.
No, because you don't need to separate this.
So you're giving me a clap because I'm not separating them.
No. I'm giving you a clap because you're saying 9 times 4. You
Oh,
cannot
because it's
multiply.
divided.
Yes, you cannot divide. Guys, this is a very important rule. A times n times b times n cannot be multiplied unless the exponents are the same or the bases are the same. If the bases are the same, we add exponents. If exponents are the same, we multiply bases. But here, this has a 1, that's an n minus 1, so we cannot. Okay, we cannot multiply these two, so we'll divide both sides with a 9. What's that? 4,096. So here we get that 4 to the power of n minus 1 is 4,000. So now I have basic 4,096, sorry. So now I can use logs. Okay, what would my log look like? Log base for what comes inside? 6 is equal to?
N minus 1.
Well done, ladies. No. 2 to the power of 2. Yeah, what is that? 7. Okay. You say so. N minus 1. So what was this? Was this 6?
Yes.
Oh, that was 6.
Yes.
Okay, plus the 1, n is equal to 7. Okay. Great. Well done, that wasn't too bad, eh? Fairly simple 5 marks. Okay.
This one, so please.
We'll get to that one when we do quadratic. Okay, the following is a combination of an arithmetic and a geometric sequence. Okay, it's not very difficult. Write the next 2 terms of this series. So we can see here's negative I, negative 5i, negative 25i. What sequence is the one with the i's? That's geometric. So what would the next one be? So negative 125i. Okay, now let's follow the constants. 4, negative 1, negative 6. What's happening each time? Minus how much? Minus 5. So if it's negative 6, what would be the next one? Negative 11. Most people got this wrong because they just put in a comma there. Write down the next 2 terms of this. Series, which means there must be a plus in between, or in this case it would be a negative. Okay, so that's unnecessary, just not answering the question. Okay, find the sum of the first 16 terms. What is your suggestion? In terms of I.
No. 16 is a lot.
No, that's okay. Oh, you'll write out all 16 terms.
I'm just saying 16 is a lot. So
Yeah. Not that much actually. There's already 1, 2, 3, 4, 5, 6. But you're right, it's a lot.
But 2 marks. But for 2 marks.
No, for 6.
For 6 more, I do it.
Is it?
I do it.
Okay, but it was originally when the question is actually 25 terms. So,
Oh.
okay.
But still 6 marks, I do it.
No, guys, what is this? Find the
Sum.
sum. So what formula? Okay. Sn. Which one?
See what it means. Because you're not asking for the sum to infinity.
No.
So using that one, yeah.
Okay. But
It
guys,
doesn't have A.
no, be careful. You're not thinking. The following is a combination of arithmetic and geometric.
So,
But the one in terms of I is sure.
Yes.
So we can isolate it.
Okay, so we're going to isolate it. So we're going to work with this term, that term, and this term separately, isn't it? Okay, so we'll first do that terms, those many terms. So the one with i's. So I don't need to worry. Whatever I get, I'm just going to multiply it with I. Whatever my sum is, I'm going to multiply it with I. Okay, so for example, I now have, it was negative 1i plus, or negative 5i, negative 25i, negative 125i, negative, okay. Now all I'm doing is I'm taking out an I as a common factor. So negative 1, negative 5, negative 25, negative 125, all the way until I get to 16 terms, okay, with I. So in other words, this is my sum, and I'm just going to multiply with an I. That's why they say in terms of I. Okay, does that make sense? Now how many terms are there? Should there be? In other words, I'm calculating Sn. Okay, A is what? You could have done that if you wanted to. If you wanted to do that, that's fine. Okay, so let's do it like that, the way you wanted to. So, A is equal to negative I, my first term. What is my constant ratio? What am I multiplying? Let's do it. Negative 5i divided by negative I. Negative cancels, i's cancel. What is my constant ratio? 5. How many terms are there? That was the trick here. Find the sum of the first 16 terms of this series.
No, sir.
Yeah.
Because we have two.
Yeah. 8. You understand why, Olivia? Because I'm only adding the i's, and the i's is every second term. It's not tricky. Yes. No. Very few people do. You know why? You don't think. But that's the trick. That's the trick in maths. Before we answer, think. Okay, that's good. So 16 terms, at least your way, if you would have written out all 16 terms, you would have seen, oh, there's only 8 terms with i's in it.
Yes.
Okay, so we're actually calculating to the power of 8 divided by 1 minus 5. Sure. I don't think I know what's 5 to the power of 8. 6,025? Is it big? 39,625. 39,600. So 1 minus that.
Minus 1.
No, 1 minus that. Divided by negative 4. So let's rather keep it as a fraction. So just go back with your ST.
Okay, it's 390629 divided by 4.
390629 because we subtracted the 1 over 4.
So
are you sure?
1 minus.
Yeah. So I agree. I think no, because the bottom is also negative, so the negatives will cancel out.
It's 1 minus 5 to the square root of 8.
Yeah.
Divided by negative 4.
Yeah, but show me. Why are you saying this?
To the power of 8. Sorry.
No. Look, you must have it in brackets.
Or
this is a fraction. So in other words. Over 4 times I with a negative. Can you see what you're doing wrong?
Yes.
Yeah. So be very careful. 1 minus that, then you get an answer divided by -4. Okay, do you understand? Okay, cool. So that is just half of the question, so half of the marks. The other half goes for what? No, that's just, is this the final answer? Guys, just because they say in terms of I, doesn't mean you only look at the I terms. They didn't say the first 16 I terms. The first 16 terms includes the geometric and the arithmetic terms. But your answer will have an I in it. That's what they mean in terms of I. Your answer will have an I in it.
So we also have to do an arithmetic series.
Yes, so we have S, again 8 terms of the arithmetic series, 8 over 2. The first term for the arithmetic series is 4. And then, so it's 2 times 4, which is 8. 2 times 4 plus n minus 1, which is 7, times d, which we said was -5. So this is 16. 4 times 8 minus 7 times 5 is 35. So this is 4 times -27. Of course you can't add it because the one has eyes, the other one doesn't have eyes. He's blind. Okay. Make sense? Okay. Okay, so let's look at this one. This is also geometric. A ball drops from a height of 18 meters. Each time it bounces back up, it reaches a third of its previous height. Calculate the total vertical distance that the ball traveled from the time it was dropped until the time it stands still. Okay, so if we just draw yourself, guys, do yourself a favor and actually draw it. Yeah, not yourself, but I guess. So here it falls at how high? It started at 18 meters, they said. Then it bounced back up a third of the height. So how high did it go? No, stop using your calculators. What's a third of 18? 18 divided by 3. Good, so then it bounced 6 meters and it falls back down, and then a third of that is 2 meters. Okay, so now what I want to show you is here, if you drew the picture, they ask what's the total vertical distance. So in other words, it's 18 plus 6 up plus 6 down plus 2 up plus 2 down plus 2 over 3 up plus 2 over 3 down. Do you get that? Total vertical distance, and this goes on. So again, what do we notice? There's a combination. There's this 18, so let's just keep the 18 separate. He doesn't seem to have anything to do with the rest. Okay, he does, but apparently not. So let's take these apart and we just do one of them at a time, one sequence, and then we just times it by 2, isn't it? Because there's 2 of them. There's 2 of these sequences. So I'll take this sequence to infinity for this one, which is my first term is 6. My constant ratio is a third. 1 minus a third. I'll get an answer, 6 divided by 2/3 is equal to 9. That is the total he would bounce up. But now I multiply it by 2 because he still has to come down. So 2 infinities would be the distances he goes up and down would be 18. And the original distance was 18 as well. Okay, so this is 18 plus 2s infinities is 36 meters.
Is there another way?
Like, I understand why okay, no, I don't understand.
Okay, so tell me, where did I lose you? Did you get this? Do you see how guys, the challenge with these questions when it's word problems is to get, what do you know about balls dropping and falling and going up and down? Like, what if it was other things like in the control test we had a guy an architect building a theater and things like that, and in the exam it was a bunch of cans being stacked on top of each other. Like, when we don't expect you to know anything about cans stacked on top of each other, we don't expect you to know about balls dropping and acceleration and those type of things. All we expect you to be able to do is get out of that context into a number pattern. Find the number pattern. So in other words, do you think you could have gotten this?
No.
Okay, so why was this confusing?
I would have just not considered going down. Like, I would have just said 18 plus 6 plus 2.
But then it's because you didn't think. Because just think about it. They ask you for the total vertical distance that the ball traveled. So if he travels 18 meters down, then he jumps up. So in other words, was it necessary to draw the sketch? Yes. So you must draw the sketch. Now you must say, look at all the distance he traveled. He traveled 18 down, so 18. Then he traveled 6 up, 6 down, 2 up, 2 down. Plus 2 over 3 up, 2 over 3 down, plus, and now 2 over 9. So now each time you're going to multiply with a third. Because
So say if you didn't think of taking out the repetitions, would it still be possible to work it out?
no, because then you'd get, I didn't give people marks for that because it's a problem solving question. It's a level 4 question. So if you didn't recognize the story, I didn't give you any marks because it's level 4 is the highest. It's only 15% in your test, 10%, 15% in your test. That's level 4 questions. So I don't give any marks if people just hodl something. They just bubble up some sort of idea. Most people, know what most people did? 18 divided by 1 minus 1 over 3 is equal to. Okay, and so yes, that's true. That would be this height plus that height plus that height plus that height plus that height. So they added up all of the heights to infinity. But that's not the distance that the ball traveled. He traveled up and down. Does that make sense?
Okay, so one last question. So when we got to the two, what is that? 2 sum to infinity equals 18.
Yeah.
And then you said 18 plus 2 sum to infinity equals 36. Why did you say 18 plus?
Okay, so sorry, I may be just going too quick to explain what I'm doing. Okay, so this is our number pattern. Okay, we've got this number pattern: 18 plus 6 plus 6 plus 2 plus 2 plus 2 over 3 plus 2 over 3. How about you guys try and find a way to find the sum to infinity for this? So let's just say you were able to get here. Now I'm asking you to find the sum to infinity of.
18 is the first term.
So this is what I'm asking you. Find the sum to infinity for this. So if you want to use 18 as your first term, go ahead. So it doesn't, I'm not saying it's wrong. There's a way that you can use 18 as your first term. But so just do the best way you can find the sum to infinity for this. Okay, so there were really a few ways you could have done it. So you could have separated. So let's say up, all down, all the downs. The downs were 18 plus 6 plus 2 plus 2 over 3, and that will add up to, now it's a geometric sequence. It's 18 over 1 minus 1 over 3, which we saw was 27. Now the ups, all the upward distances were 6 plus 2 plus 2 over 3, etc., etc., etc. Okay, notice that the difference between the upward distances, no, it won't be, sorry, okay, is equal to 6 over 1 minus a third is equal to 9. Okay, and so now when I add these up, I get 36. That makes sense, doesn't it? Yeah. Okay, so they're distinct. Another way you could have done it is just adding them together, like these ones. So in other words, we get 18, okay, but because we're adding up 2 by 2s, and the first one doesn't have a friend, let's just give him a friend, and in the end we'll just subtract it. You understand it? So in other words, let's say this is 36, plus 6 and 6 is 12, plus 2 and 2 is 4, plus 2 over 3 plus 2 over 3 is plus 4 over 3. Let's see, is this geometric? Yes, because this is a third, I mean. This is a third, that's a third. So it is. So the sum to infinity for this one would be 36 over 1 minus a third, which is equal to, this divided by 2 is 18 times 3 is 72. Nope, 54. 54. But I added an 18 here, so I just remember to subtract it in the end. So minus the 18, which gives me 36.
Like that one. Like these ones.
There's many different ways you could have done it. Well, there's probably more different ways that you could have done it. For me, the way it made sense to me was that I had 18 to start with, and then I had the sum to infinity, 6 was my first term, and that one was my, but this only represented the upwards. So I must multiply with 2 because there's a downwards as well. And so that's what I did, for example. And this gave me an equation that also goes to 36 meters. It's more than one way to do it, but it comes down to being creative with your sum to infinity formula on an expression where every term separate doesn't make a geometric sequence. It's every second term that makes the sequence. Okay, good. Let's go to the last topic.